Hello everyone. So today we will learn how can we create our custom container using only Linux command and without using Docker. All the code files which are used in this particular project are provided in this GitHub repository, and link of this GitHub repository is provided in the description. So let's start. So first of all, for a container, we will be needing our one custom file system. So what we are going to do today is create a Nodejs application, uh, create a separate namespaces for that, and provide a separate cgroups functionality to that particular application. So for that, we have to have one like bootstrap file system on which we can run our application. Like here, you can run this particular command, debootstrap. So what is debootstrap? Debootstrap is a system which can provide you for a starting file system. Like in my case, I have already installed it. So let's create my starting file system. Like I will be using these particular commands via this file because if I just type it out, it will be boring for you. So okay, it can be only run via root, and also it will be needing a directory. So let's create a directory and run it via sudo. So it will retrieve all the necessary dependencies which are necessary for creating your file system. So it has installed a Debian system on my system. So like here, if we can see, like my own system OS release is Ubuntu 24 LTS. Although the container which we have downloaded, no, not the container, the file system which we have downloaded has this particular OS release. See, Debian GNU Linux. So what we actually have done, we have created a starting file system which has its own binaries and own library. So here we can pack on with our custom code and run it. Like if I do Chroot, like Chroot dot slash containers, so I have now jailed my file system to this particular file system. Whatever I execute here will be executed on these particular files. But I will be needing other processes like process IDs. Okay, we don't have process here up till now. So maybe, as you can see in these particular binaries, it's the bootstrap file system. It doesn't have PS or it doesn't have functions like ping in it. So we have to install these things in it. So what we are installing? We are installing IP utilities ping to check network connection. We are installing pro CPS for checking processes. We are installing nano editor, Nodejs, and IP routes. So why IP route it's needed, you will be able to know further down the video. I believe it has one S. So in our Chroot, all the utilities are installed. Like now, ping is also recognizable. See, so let's go ahead and make this particular thing in a separate namespace. So let's run it in a separate namespace. So for that we will run sudo unshare. We will create a separate mount for it. separate process ID namespace, separate user hostname, network, cgroup, and what else we can do? We will fork the process, binary, bash, so yes. So here we are now in a separate namespace. So let's try running ping with 3 packets to our google.com. So now it says temporary failure in name resolution. So what basically it has done is it has given us a separate network namespace, but our network namespace is not connected to the internet. So to connect it to the internet, we have to run following script. Like for that, we will create a separate network namespace. So let me explain you about it a little bit. We will create a separate network namespace named my network namespace. So after that, we will create 2 veth pairs. One will be named as system at, which will remain on our host side, and another will be named as container at, and which will remain on our network namespace side. And we will allot IP addresses 10.0.1 to our system at, and we will allot IP address 10.0.2 to our container side veth pair. So these veth pairs we have created so that our isolated system can have a communication when we do Chroot, because whenever we do unshare net, all the network capability get lost to our namespace because we don't have any connection. So for that we need to run my network namespace. Like here we can do like these commands are used. First we will create a network namespace. After that we will create a veth pair called systemat and containerat. So veth pairs are created in pairs only. So after that we will set container at pair on the my network namespace side. Like we have this particular point, like veth pair is allotted to network namespace container at with container at name. So to this part was done. After that IP address was allotted. System at has got 10.0.1 and it is set to up, and container at has got 10.0.2 and then it is set to up. We have also set up the loopback interface of my network namespace, and then we have enabled the IPv4 packet forwarding in our host. Like these particular settings within your host you can revert by another file which is provided in the repository. And after that we will create a NAT rule by which the routing has happened between, like you can see this particular rule here. Here actually whenever our network namespace will try to route any packet from its network, it will go via our system at namespace. Like this 10.0.0.1 is the IP allotted to system at pair, like here. So we have added a route by which it will use this one. Like here, basically, suppose there is one particular data packet 1 is generated here. So it will go through 10.0.1 to the internet, because here this setting we have added. like here we have added this particular setting. Okay, so after that we are just checking like whether a ping is working. This 8.8.8 is a name server, like it's a universal name server which is used for resolution. So that's what all is done by create network. Let's move forward. So we will do bash create network.sh. So it is forwarding IPs, IP packets. So here, let us just go out and then run this command. After that, we will go inside our network namespace. So it can be done sudo ib network namespace execute my network namespace Chroot to our file system. So now let's try ping. So now our ping is working fine. Let's try ping to a named DNS. Okay, see, so it is unable to resolve. So if we can see in our Chroot whether we have any resolve.config. Grep resolve.config. Okay, we do have. So nano etc resolve.config. So it seems it is copied from the base file system. So we will remove all this content and give it a named server. So now let's try. See, after giving name server, it is able to resolve. We have transported 3 packets to google.com and it worked fine. So now our like Chroot system is able to do the communication with outside world, and also like we have created it using unshare process ID. So processes must be uh, like different here, but here some more things are remaining. Like let's do some more mounts. So here we will mount type proc to a virtual interface proc and mount it to process. So by that we got our separate processes in our isolated container. In same way, run other statements for system files. Mount temporary file system. So now all the things are mounted. Let's create our application. Like here we have one application called server.js. Let's copy it. We have downloaded a nano editor. So what it is doing, it is just sending this particular hello, this response is from container to port 3000. So before that, before running this particular application, let me show you one thing. In network interfaces, you can see it has one loopback interface and container at pair is here, which have IP 10.0.2 allotted, like I have shown you in this particular script. Like I would have typed these all commands in front of you, but then the video would have become boring. So I have created a script already for this. So here we have attached this particular IP address to our container at veth pair. So as we can see in our separate container, in network interfaces, we have this particular IP available. And likewise in our local, we have the other pair, like this one, system at. This system at and this particular container at are connected, and this particular IP is using this as router to route packets. So let's run our server node server.js. So our server is running. Let's do curl. See, it's worked. Hello, this is response from container. So our host system is able to connect to our container. So now what last thing is left, we have to allot the cgroups to our this particular container. For that, let's see what are different processes running. Like I will see for my network namespace that I have just created. So this one is the sudo process, first one. Second one is the actual my network namespace process, and this one is the grep command process. So this 11 to 87 is basically my process. So let's see list processes 11 to 87. Okay, so as we can see, we have cgroup here. Let's see what exact cgroup it is currently using. Like if the terms I am saying here are like not familiar to you, please go and watch the previous lecture in this series. So here, our process, network namespace process is currently using this particular C group. So now we will modify it so that it will use another C group with our pre-allotted CPU and memory. So let's go to system, file system, C group. So here we have different C group. Let's make my C group. So my C group is created. So now I will modify, like from now on, this part is quite like dangerous, I will say. Whatever commands you type here, there are also revert command given in the repo. So please follow that, because this particular thing can change your whole system setting. Let's run this particular command. What this particular command does is it will provide you capability to modify CPU also in your C group. So it's done. So we have modified our C group to use these particular CPU and memory. And from now like we can see we have one file named cgroup procs here. Like this particular cgroup proc file, we can add the id of the process to which we have to allot this particular cgroup. So let's go and do nano cgroup dot procs, and what was the id? id was 11287. Run it by this 11287. Okay, so yeah, now these particular cgroup settings, like CPU max limit to 50% and some these particular number of bytes to the memory is allotted to our process number 11287. So let's see how much C group, like which particular C group now this process is using. So now this process is using our own my C group that we have just created here, and here we have specified like in C group CPU max and memory max, like this particular CPU and memory this container can use. So by this our, and also we can recheck the capability, like whether it is running currently or not. It is still currently running very fine. So by this we are able to create a container which has separate namespace, separate network namespace, and separate C groups. So now we have created so much different setting within our Linux system. So that's why I will advise you to use a different virtual machine for this task, so that if anything goes wrong, like your major operating system should not have any issue. But still, let's go and revert the changes that we have done. So first of all, let's kill this process, exit. Now our network namespace process is killed. Okay, it is killed. And my C group we have to delete. Before that, we can do these particular settings. And at last we will remove this particular C group directory. So our C group changes are reverted, and at last we will also revert the network namespace changes. So we will run bash delete network namespace. So our all settings are reverted now. So that's how we can run our own custom container in Linux. Like you can rewatch this video again and again, and this time I have kept video length very small because previously I have received feedback that my video was very long. Like my case for that was like maybe for a person watching my video, it just these things can be new. So like I can keep small pace, but YouTube works differently. It works on the number of time and the percentage of time your video is watched. So that's why I have kind of kept my pace high this time and not like taken a slow pace. So yeah, that's all. If you have any doubt regarding this, please comment down below. Thank you.